Steel is no longer what it used to be. Do you know what design opportunities you have with today's steel? My name is Patrik Öhlund and I will talk about new design opportunities in steel. Constructions in engineering steel is in most cases subjected to cyclic stress of a long time. This makes fatigue normally the limiting property. From experience, it is known that defects such as non-metallic inclusions will initiate the fatigue failures. The required stress is significantly lower than the yield or fracture strength. Ovako has focused very much on fatigue research, and today we have an impressive database with fatigue data. We know and can show that the steel quality can have a huge impact on the fatigue life of a component. We have looked at thousands of fatigue failures. In our scanning electron microscope, we determined the position, type, and size of all failures. We know exactly what stress that was required to initiate a fatigue crack. Analyzing the data, it is clear that a larger defect, like the one on this picture, will require a lower stress to initiate a fatigue failure compared to a smaller defect like the one you see on this picture. The data can be plotted in a graph. It is obvious that there are larger defects present at lower stress, and the lower stress is required to initiate a fatigue failure. If we add a line separating the failures from where we have no failure, we can construct a graph with a line showing the conditions where you may expect fatigue failure and not. If you remove the data points, it becomes a simple graph with two areas: a safe zone where you have no fatigue failures and a fatigue failure zone. Unfortunately, the international standards assessing steel cleanness are not capable of showing where you are on this curve. We have seen that conventional steel in many cases have significant amounts of defects in the size range around 60, 70, 80 or even larger. As a consequence, a stress around 400 megapascals will be the limiting stress. Since the slope is relatively flat at this end of the curve, there is not a dramatic effect if the steel contains a 60 or 100 micron sized inclusion. Ovako has worked long and hard to control and limit inclusions in steel. Today we have qualities that is shifted towards much smaller size range. The BQ and IQ steel has significantly smaller inclusion sizes compared to conventional steel. At this part of the curve, the slope is much steeper. This means that the gain in fatigue strength is increasing dramatically. We see this as a huge opportunity to rethink design solutions, either by reducing the weight, increasing the power density, or both. So when you face challenges in design, the BQ steel or IQ steel from Ovako may offer just the new opportunities you need.